So in this code, we are going to see how the accesses to the shared memory locations are annotated with which orderings. In order to do so, we search for ordering here. Okay, so far so good. And for the drop, we don't need to annotate anything with acquire or release. The reason is that at the time that a data structure is dropped, then we fully own the linked list. So we don't need to synchronize with each other. We don't need to synchronize with other threads. That's the reason why we can just use relaxed here. There's no release or acquire in order to synchronize with the other threads. And now the next thing to do is the heuristic find. Okay, now let's understand why the next pointer, reading the next pointer of the current node must be acquire. So recall that the cursor is consisting of two pointers, the previous node and the current node, pointing to previous and the current node. And in the next iteration, we are going to move the window of this, and the current node is becoming the new previous, the new previous node, and the next node is becoming the new current node. The reason why this must be acquired is that in the next iteration, this next is becoming the next iteration's current pointer, and this current pointer is the referenced here. It is referenced here, and its value is actually read here. So that's basically what's going on in this implementation. Next pointer is read, and it is becoming the next current node, and it is in the next iteration dereferenced here. That's the reason why it must be acquired. So in order to see the latest value of the key, for example, or at the later stage of this algorithm, key and value, we need to make it an acquire in order to acknowledge the latest information on this key and the next values. So that's the reason why this is acquire. The reason is, in a sense, to exploit the invariant by acknowledging the latest information. So the same thing happens for this as well. It is iterating. In the find Harris-Michael strategy, almost the same thing happened. We need to read the next pointer, and it must be dereferenced at the next iteration. So that's the reason why it must be acquired. This is the same as well. This must be acquired for the same reason that we iterate through this linked list, and in order to see the latest information on this next pointer in the next iteration, it must be acquired. For the same reason, it must be acquired too. So far, I explained why some of the orderings must be acquired. That is, in order to establish the invariant in the write operations. On the other hand, we are also writing something with release. Why? The reason is that we are overriding the pointer value to this previous node. This is basically the previous node's next pointer. And we are overriding some value to this pointer. And the overwriting value is the current pointer. And we have to establish the invariant that all the pointers, the new pointers of the self.pref, which is pointing to self.current, we need to make a guarantee that the release view of this write is greater than or equal to the information, the latest information on the self.cur. And the latest information is already acquired here. In this loop, we used acquire read, and as a result, at this point of time, in this thread has already acquired the latest information on the self.current pointer. And as a result, you can just do a release here. By doing so, we are releasing the information, the latest information on this current pointer to the message of this self.pref. So in other words, it is effectively re-establishing the invariant that this pointer, its release view is greater than or equal to the latest information on this current node. The almost same thing happens in this release as well. So you can see that the code is almost the same, and that's the reason why it must be released. And also, that is the reason. We don't do a release right here because in find Harris-Holly, in the Harris-Holly-Chavez strategy, we are not going to fix the list by updating the linked list. So we are not overriding the pointer value in this strategy. So that's the reason why there is no release rights. And that's basically particularly the reason why it is weight-free. Even though it doesn't have a compare and swap, so it will always succeed in iterating through the linked list, and that's the reason why it is not the faster than other traversal algorithms. At the cost that maybe the other threads may suffer a little bit more performance problems. Okay, so far so good. And you may wonder why this be relaxed. The reason why this is relaxed is that in this implementation, we are only reading the pointer value. Actually, we are only reading the pointer tag of this next pointer. We are not dereferencing the next pointer. That's the reason why it doesn't need to be acquired. We are not accessing the next pointer's key value next pointer, so we don't need to acknowledge the latest information on the next nodes. We just want to know the pointer value, especially the tag value. That's the reason why it can be just relaxed. So far so good. And yeah, here it can be relaxed because we are accessing the fully owned node. It is not shared with the other threads, so we are not synchronizing anything. We are just writing some value here. So that's the reason why it can be relaxed. It must be released for the same reason that the previous compare and swap must be released, and on and on and on. So I guess that you may be able to reason why this should be, it can be relaxed rather than released, for example. And please at home, please analyze why all the orderings are safe and enough, basically. Okay, so far so good. And as I just said, please list up all the orderings: acquire, release, and relaxed. And for acquire and release, please understand why they must be acquire or release. All orderings have a reason. The reason is to establish the invariant. So with respect to the invariant, please justify why they must be acquire or release. Why they should not be just relaxed. Please understand that at home. And if you understand some of the orderings are why such defined, please ask a question as precisely as possible. And furthermore, for this relaxed ordering, please understand why these kinds of orderings can be relaxed. I already explained that some of them are relaxed. They can be relaxed because of some reasons. So please understand them for all the relaxed orderings that is presented in this code. So that's basically the explanation of the orderings inside this code.